Alright, start off with, we're going to create a sprite. I'm actually going to create two sprites. This first one we're going to name player. The second one doesn't matter because we're just using it as ground for right now. And player, we'll do that now. I'm going to probably make these both just a tad bit bigger, especially player. On both of these, we need physics 2D, and we're going to put on a box collider. And on the player, physics 2D, rigid body, and also, yeah, we'll just keep them on the other objects. All right, player, you can tag it as player. And now let's go ahead and create some scripts. I'm going to take this and drag this onto player. Really? Want me to compile it first? That's fine. So what? For what I'm doing, it's going to be fine. For what we're doing, it's going to be fine. Let me reiterate that. Alright, I do need late update, which is a built-in method. And I'm just going to build this first because I just want to go ahead and attach it to the player. There we go. Alright, so we're going to create two things. We're going to create a vector 2. We're going to name it direction. We're going to create a float, speed. We're going to create another float, jump. We're going to create another float, jump height. We're going to create a bool. It's grounded. Now, two things. So what? Two things. One, is grounded is a component or attribute of the actual character controller. I'm not using that, but literally how you access it and what it looks like looks the same as what we're using here. We are not using a character controller. I'm just using the bool is grounded, and I just want to point that out. Now, late update, we're going to use this to control our physics. Update, we're going to use it to control everything else that we need to calculate per frame. So the first thing we're going to do is in late update, we're going to create, we're going to go in, and we'll actually, in update, speed. No, we're not going to do that. We'll do it in here. So in late update, we'll create a float, amount to move. It's going to be equal to speed times time dot delta time. Actually, not delta time. We're going to use something else. We're going to use fixed delta time. And start. Oh, we needed one more thing that I forgot. We need to create a rigid body 2D. I'm just going to name it this rigid body. This rigid body is going to be equal to get component rigid body 2D, and then let's deal with direction. Direction is equal to a new vector 2 for x input dot get component. I'm sorry, not get component, get key. I'm sorry, get access. We're going to grab our horizontal. And then for y, we're going to use jump. Now, to actually move it, this rigid body dot add force, and what we're going to use is direction times amount to move, and we're going to use force mode 2D, and we want to use force, and we're going to hit build all. Yes. Fixed delta time, the big difference is it works better with physics, especially 2D physics in this instance. And I think that with delta time you can have a variable, because they're both floating point variables, variables, but you can have slight differences in the two, where fixed delta time is always going to be a constant. All right, and speed, let's go ahead and give speed, let's make that 2. Actually, let's make it 20. And jump height, let's make that 10 for right now. And we haven't used is grounded. I'm going to build this again. So what we're doing is getting our rigid body and telling it to do something. However, it's not doing anything. So I'm going to increase speed. Might have to do something else. So the values are a little bit high for that, so I'm going to do just a couple of quick changes. So float, I'm going to change amount to move to I'm going to declare it up here. Now that works. I want to change that. The only thing I don't like is the fact that I have to increase my values so much to get it to work. But I'm going to do just some things that are going to be up here a little bit odd, and that's fine. So it is working, it's just I have to have this value fairly high. And I wanted to kind of combat that. But that's okay for right now. The other thing that I want to do is, let's go ahead, and what I want to do is, once we let go of the horizontal button, and this is your left and right arrow buttons, is you can see that it takes it a while to slow down. because we're using physics to move it, I'm going to go ahead and use a little bit of velocity. And what we're going to do is same thing we did with the rollerball. Velocity is equal to direction times amount to move. And I may be able to decrease my values. So it gives us a little bit of control. However, the problem that we have is gravity. It's a little bit slow. So what we're going to do now is create our own gravity and use that in conjunction with it. So float gravity, let's say, is equal to negative 9.8. And direction dot y is less or equal to gravity times amount to move. Actually, we'll just do gravity times time dot fixed delta time. What's wrong here? What did I do wrong? I have a decimal there. It's a float. I can use a decimal. What am I missing? A what? Yes. Every time I have a decimal point, I gotta use F. So I'm still going fairly slow. And I'm going to go ahead and put this into my jump because I need that. So if input dot get key down, key code space, jump is equal to jump height, else we want to make jump equal to gravity. So that went a little bit crazy. Let's do I may not need this anymore because I'm using that. And we could do something else. And I'll explain what we're doing in a quick second. So you see here it is kind of going a little bit haywire. And so here right now is it just jumped. And the values are fairly high. I'm going to bring that down just a little bit to like 0.5. And what is happening is and should start to come back down. Because we have our velocity, and our velocity is controlling our direction, if I was to take this out, and tell this to be equal to 0, this is what our jump will look like. So we're up here. And we're going to make that higher. This is what we have. So I can make it jump, but I still have to contend with velocity. Now the reason why I'm able to jump and hit the spacebar multiple times and do that is for the simple fact, oh, let's get it back, is the fact is we don't have the velocity. And it's a good and bad thing. Now, I would like to keep it in here, but then I have to do some other things to keep it from not, oh, I could just do this. So we can say that. So is equal to -1 starting out, and I'll do that. Now, we do have the problem that jump is now a, how can I say this, is popping up to that position, and I don't like that. So one of the things we can do is this. Instead of having it equal to jump height, we can use a lerp. So mathf dot lerp, and then we look this up. We have our value. We got jump. I'm sorry, we have our value that we want to start out with, and is jump. We have the value that we wanted to go to, which is our jump height. And then we have how, our time, and we're going to use time.time. And then here, if we wanted to do the same thing, I'm just going to copy this. And we go jump, and then we can say here is -1 and time.time. And if I have everything correct, what lerp does is creates a smooth transition between variables or positions or colors, depending upon which type of lerp you're using. And we still got a little bit of that pop up that I don't like. So now we can try to use it with, instead of time, let's try delta time. And the value is a little bit slower. So we're going to multiply this times our speed. Still a little bit wonky. Let's make this times 100. So it's still popping up, and is all because of having this equal to -1 instead of 0. So let's see what we can do. Well, there is some more stuff we can do. So let's pretend I want to keep these two like this right now, because it is the simplest thing that we can do. It gives us movement, and we're popping up there. Let's get rid of the velocity for right now. and we're able to use more of our we're able to use a little bit more of our um, what's the word I want to say? We're able to use the rigid body, and we're able to use our momentum a little bit um, to move things. And then if we want, we could probably, well, we don't have that. We have we have mass that we can play around with in angular drag and gravity scale. I think I'm gonna leave this as here for right now, and then let whoever, whatever they want to do, go from there. Because I could do a more, it's not even more of a complicated setup. It's using our velocity with our buttons and our right and left buttons and using those together to get X, Y, and Z to happen. And I don't want to make this too much of a complicated setup because this is supposed to be a faster project. And we will get to some things like this later. Well, we're going to use this grounded. But let's use this for right now. And then we can always add to it later. So this gives us our movement. This gives us our direction. This gives us our jump, which I'm just calculating values. And then this is actually moving our object. What I want to do now is use kind of turn on and off is grounded and get that working. So void on trigger enter 2D, and we need our collider 2D and other. So what we're going to do, if other dot tag is equal to ground, is grounded is equal to true. And now what I'm also going to do is we're going to use on trigger exit, and then we're going to turn this false. Now we got two things we need to make this work. If I turn this trigger on, we hit play, we fall through it. That's no good. So what we're going to do is add in another rigid body 2D, and we're going to make it a little bit bigger in its size. And then I'm going to adjust the height as well too, so that you can't hit the ceiling and turn on is ground and make some other stuff happen. And now we need to tag it as ground. So we're going to create a new tag, ground, hit save, and this we're going to tag as ground. Oops, let's turn on our trigger. Oops. And this other trigger, let's turn that off. There we go. There's not two rigid bodies, there's two colliders. One collider is for us to stand on, the other collider is for us to dictate if we're standing on ground or not. Now let's check to see if this is working. So this right now is private. We're going to just make it public. Let's select our player as grounded. And it's working. That's what I want, and that's so that I can't, well, what we're going to use it for, so I can't keep hitting the spacebar and make it fly off into the distance. Oh, something happened there. Okay. Now, what we're going to do is we're able to use our spacebar to jump if we're grounded. So what we're going to do, input get key down, and what we're going to do, and if, I'm sorry, is grounded is equal to true. And this is only going to affect our jump. So I'm hitting it multiple times. And that's what we get. I could probably make this a little bit smaller. Like right there. And then, you know, just a smidge so that it doesn't like it's not that big. So you don't look like you're hitting that because it's bigger and going through there. And that's all I did. So let's talk about what we did. So this is our move direction. We will and let me do this before we lose.